Hello, it's Elixir Code Girl here, and today I'm going to take you through how to run code concurrently in Elixir. So this is the first series, and there'll be more series coming after this. In this first series, we're going to learn about what is concurrency, what is synchronous and asynchronous code, and how to write code concurrently with the task module. So what is concurrency? So I'm going to give you a real world example of what concurrency is. So I'm going to talk about our motherland, but let me be specific, Kenya. So whenever we receive a visitor, we usually like to welcome them with tea and bread. That is a norm to us. So let's say a mother is cooking tea in the kitchen, and at the same time, she has sent her child to the shop to buy bread. So the task of cooking tea and buying of bread have been performed simultaneously at the same time. So this is what is referred to as concurrency. So the mother did not wait for the tea to be ready in order for her or for her child to go for the bread. So that will mean if they're serving the tea to the visitor, they will serve together with the bread. And this saves a lot of time. Then let's look what is synchronous code versus asynchronous code. So we have mostly interacted with the synchronous code, and this is what we have been writing mostly in our Elixir code. So when you run code in Elixir, you have to wait for it to complete. So this is also known as blocking of code. So that means the code is executed synchronously because we have to wait for code A to complete in order for code B to run. So we can look at an example of how this works. So I will go straight to my code editor, clean up this first. So in here, I have a chat app application. So it's a simple chat app application. So the intention of this demonstration is to send messages to the given number. So the business logic in here, we shall assume that it takes 4 seconds for a message to be sent to a given number. So it's just like in a real example whereby when we send a message using a third party API, like a business logic, sending a message will require us to have a third party API. And this will mean sending a request via an API. So when handling the API, we need to consider that delays might occur before receiving the rest. The purpose of the process the sleep, it will emulate a slow operation that takes few seconds to complete. So in this function in here, we have a process to sleep, which will sleep for 4 seconds. So then after those 4 seconds, it's when the message will be outputted to our terminal. So the message is a message sent to the given number. Then after that, our status okay is received. So this is a simple part of it. So let's see how the send message works. So we're going to have the send message. Send message, then call the send message function. Give it a simple number, 1, 2, 3. Okay, so we wait for 4 seconds. Then we receive the message and the status. Okay, so now what happens if we want to send to more than one number? So first I had created a variable numbers, which is a list of numbers. So in here we are going to we are not going to send messages to all these numbers. So what happens if we run this code synchronously? So that's the fun part of it. Notify all synchronously, give it the list of numbers, wait for 4 seconds for the first message to be sent, wait for another 4 seconds for the second message to be sent, wait for another 4 seconds for the third message to be sent, wait for another 4 seconds for the fourth message to be sent, wait for another 4 seconds for the fifth message to be sent. So that means we have waited for like 60. We waited for like, yes, 20, sorry, we waited for like 20 seconds for all the messages to be sent. And that means message A must complete for message B to be sent. Okay, that's not good. Okay, so that is synchronous code. Now let's look at the asynchronous code. So the asynchronous code is the opposite of synchronous code. So that means you can run more than one program simultaneously at the same time. So it's concurrent because we can perform other tasks. So asynchronous code is similar to concurrent code. Let's look at how asynchronous code work. So in here, defined two functions. There's the synchronous and there's the asynchronous code. So in the synchronous code, we saw how the messages are being sent one at a time. Now let's look at asynchronous code. Notify all asynchronously. Give it the same list of numbers. Okay, so we have an atom. Okay, so that's the output that is received whenever you use enum.each. Then after that, you can see that all messages have been finished at the same time. So this concurrency has worked, has it's something that has worked on the background. And you can see that we have finished all the messages have been sent at the same time. So this is a good scenario of demonstrating concurrency code. And also it's a practice that we need to add in our business logic. So whenever you're creating a software, it's always good to put concurrency in mind. So thank you very much for watching this video. This is the first series. Look out for more series on concurrency. Thank you.